12.2, day 3. The longer we go on a section, the lazier I get with its title and shortening it. So, we're continuing to add and subtract rational expressions. Today, some of the problems are going to look a little different, though. They're going to look a little bit more like this type of rational expression. That's a 5, by the way. Now, we talked about rational expressions similar to this in 8.1. Close the laptop, please. But they were slightly different. Does anyone remember what these are called? 2 words. First one starts with C. Complex fraction. When you have a fraction inside of a fraction, it is a complex fraction. Now, one of the things that I mentioned with complex fractions is you're going to want to take a look at the biggest fraction that's there. Specifically, the biggest fraction that's here on this one has the 1 over 2/3 as its numerator, and, 1 plus 2/3, and the 2/5 plus 2 as its denominator. And I mentioned that you want to kind of take a look at that first and double check if that numerator and if that denominator are just a single fraction. Are they in this case? No. And if they're not just a single fraction, then we do not want to go directly to changing this big fraction bar into a divide symbol. I mentioned that that would come up, but we hadn't seen it yet. So, because this is not a single fraction and this is not a single fraction, I don't want to change this to divide yet. Instead, I want to get it to become a single fraction. How do I get 1 plus 2/3 to be just one fraction? You start adding them. In order to add, what do we need? Common denominator. 1 with a common denominator would be 3 over 3. Because it's currently 1 over 1, technically. Over 2/3. And that denominator, 2/5 plus 2. 2 would be what over 5? It's currently over 1. Common denominator is 5. To change it into a 5, it becomes 10 over 5. And now that I have the common denominators, I can do the addition. 3/3 plus 2/3 is 5/3. Over. 2/5 plus 10/5 is 12/5. So when there is multiple fractions or multiple terms in that numerator or in that denominator, you need to get to adding them first. And then a fraction bar is nothing more than a division symbol. Then we can change this to divide. So now those skills that we gained from both 8.1 and 8.2 are starting to move together. How do we divide fractions? Keep, change, flip. So, 5/3, keep that. Change the divide into a multiply. Flip the other fraction to 5 over 12. Do we need a common denominator in order to multiply fractions? No. We simply multiply straight across. 25 over 36, and simplify if possible. Is it possible? No. 25 and 36 do not divide by the same thing. 25, the only thing it divides by is 5s. 36 does not divide by 5. Just addressing one of the common errors that I see in these problems real quick. Could I have simplified when it was over here? Can we cross simplify? With divide? No. When can you cross simplify? Multiplication only. It would have had to have been able to simplify with cross multiplication. Or with, not cross multiplication, when it was in multiplication. So, just be careful with that cross simplification. Okay, so that's what we're doing today. Ooh, I forgot to write simplify at the beginning of my notes. Oops. Guess what? We're simplifying. I'm going to write it here. Because these are the first ones that are going to get into having more of those variables involved. Oh, by the way, I'm actually going to show you 2 different ways to do this today, in case you're interested. So, based on the way that we just did, we're going to tackle this problem. Now we've got some variables involved. Now, when there's variables involved, we have to remember some of the things we've already been talking about when it comes to adding, subtracting, multiplying, dividing, and simplifying rational expressions. One of the things we have to pay attention to, if we're going to go through and do some adding and some subtracting here, which we are going to do first. Yes, we need the common denominator, but in order to get said common denominator, if there's addition and subtraction in the fraction, then it might require some factoring. Now, when I say in the fraction, because obviously there's addition and subtraction in these fractions in general, I'm talking about the piece that we're actually adding and subtracting right away. A 1 doesn't have any adding or subtracting built into it. Does that fraction? No. So, I don't need to factor anything. If it did, I would have to. Okay. So instead, I need these 2 things to have a common denominator. Remembering 1 is just over 1. And our common denominator would be x. How do I get 1 over 1 to become something over x? Multiply the top and the bottom by x. X over x plus 1 over x. I'll be honest, when I'm doing this, I tend to ignore the denominator for a bit, and I just kind of work with my numerator, and then I go back to the denominator. I just leave a place for it. Okay. I add my fractions. X over x plus 1 over x becomes what? X plus 1 over x. Okay, there we go. My numerator is now a single fraction. So I move on to my denominator. I've got a 1 again, remembering that it's 1 over 1, and a common denominator here would be y. So I multiply both the top and the bottom of this by y. I get y over y plus x over y, and now I can add. And now I can subtract. And I get y minus x, I heard someone say, over y. Once I have this now, what do I do? Y'all can say it a little bit louder. You've been like whispering answers to me today. Don't get me wrong, I got pretty good hearing and I can tend to hear you guys, but that's only if I know what you're gonna say. Keep, change, flip is what I heard. Or I could change it to divide right now. Would you prefer to me write divide, or do you want me to keep, change, flip right away? Okay. X plus 1 over x is the part we kept. The change was right here to a multiply. This got flipped. I'm multiplying. I see addition and subtraction. My brain is thinking, okay, I have to at least attempt to factor. Can I factor x plus 1? If you can't factor it, but before you multiply it, what do you need to remember is technically there? Parentheses around it. Monomials, don't need them. Pluses or minuses need them. X doesn't factor. Y minus x, can I factor that? No, it's in parentheses. Multiply fractions straight across. Remember to put monomials first. I get y and an x plus 1 over x. And a y minus x. Is anything going to simplify? It's already fully factored. The y and the x do not simplify. Those aren't the same. That's it. So, complex fractions. When you've got addition or subtraction. Really just kind of putting things together that we've already done. The big thing about them, though, is they can get to be a little tedious, especially in situations where you have to do some adding and some factoring in order to do that adding and subtracting. So actually, there is another way to do it. In the end, I don't care which way you prefer to do it. You just have to know one of the two ways. The advantages of each of the ways. The first way I taught you is the way that's more intuitive. If you look at the problem, I have no doubt that if push came to shove and I gave you this problem without any sort of background information on how to approach it, many, if not all of you, could have gotten through and done the problems this way eventually. Maybe this one you would have gotten stuck and said I wouldn't even try. But haven't I given you this, most if not all of you, if I said you had to get it done, would have come up with some semblance of this. The second way is less intuitive. It's not as obvious on how to approach it, but it is shorter. So, I know I already wrote simplify, but there's a reason I'm doing this. Simplify, version number 2. You might notice something about this problem. Probably looks a little familiar. In fact, when I start teaching these two different versions, I always start with the same two examples and do them twice. That way you can get a sense of each version with the same problems and make a decision about which way you want to get better at or which way you want to practice that you think is better for you. Because there will always be some people who prefer the first way, there will always be some people who prefer the second way, and either is fine. Okay, this version though, I have to write instructions along the side because like I said, it's less intuitive. So when you're doing this, the first thing you're going to want to do is find the least common denominator of all little fractions. And when I say the little fractions, I mean the 1, the 2/3, the 2/5, and the 2. All of the fractions that are inside that biggest fraction. The 1 and the 2 are both over 1. 1 doesn't really affect a greatest common factor or least common denominator. 3 and 5, least common denominator between those two, 15. Next thing you do is you multiply that least common denominator, that LCD, by the numerator and denominator of the big fraction. So, I'm going to multiply by 15. I'm going to multiply by 15. Now, when I do that, I have to keep a couple things in mind. I have to remember that that 15 is getting multiplied not by one of these two little fractions, but by both of them. And how do I multiply a whole number by a fraction? Remember that it's over 1. So a couple little reminders is that it's over 1 and you need to distribute. $15 over 1 times 1, 15. 15 over 1 times 2/3, 30/3. 15 over 1 times 2/5, 30/5. 15 over 1 times 2, 30. From there, your little fractions will always all simplify. And they'll simplify in a manner that they will no longer be fractions. The denominator will always cancel out completely. 15 plus 10 over 6 plus 30. And you simplify now the big fraction. 25, I wrote 36 accidentally, that was a 30. And we get 25 over 36. So, this problem was the exact same as the first one. 1, 2, 3, 4 things written out, 4 steps. The first one, 1, 2, 3, 4, 5, 6 steps written out. It's a little bit shorter. It's not tremendously shorter all the time. It will get more noticeable on harder problems. Okay, our next problem, I already told you what it was going to look like. I told you I do the exact same two problems in both versions. So, 1 plus 1 over x all over 1 minus x over y. I look at all those tiny little fractions. What would be their least common denominator? XY. Multiply it by both top and bottom. Remember it's over 1. Remember I have to distribute. XY times 1. XY. XY times 1 over x. Now, some of you might simplify this fraction as you do it, and I'm okay with that. For the sake of our notes, I will not. But if you jump directly to what I will be considering the next step, I'm okay with that. I'm just going to straight multiply. 1 times xy is xy, and x times 1 is x. Denominator, xy minus x squared y over y. We then simplify the baby fractions. X over x will cancel, y over y will cancel. I'm left with xy plus y over xy minus x squared. The last thing we're supposed to do is simplify. Since there's addition or subtraction, if I want to simplify, I would factor. Numerator, I factor out a y, I'm left with an x plus 1. Denominator, I can factor out an x, I'm left with a y minus x. Does it actually simplify? No. Is it the same thing I got doing the other version? Yes. Again, a comparison. The first time I did this problem, I wrote it out in 1, 2, 3, 4, 5 steps, skipping the fact that I typically change this complex fraction into dividing two fractions. I went directly to keep, change, flip. In this new version, I did it in 4 steps, but many of you, if this is the way you prefer, would be able to go from this first step to this step. Because as you multiply those, you can cross-simplify. Which way you do is up to you. Okay. I've got 2 more examples to give you a little bit more practice of choosing whichever way you want. And also, these 2 problems are a little more complex of doing the same thing. Simplify using either method. Now, here's the thing. I am not about to stand up here and do both versions every single time. I'm going to choose one version. Which way I do is going to be kind of where the majority of the class is. Who prefers version 1? Couple people. Who prefers version 2? More people, and then there's a bunch of you that are like indifferent, I'm guessing. Okay, more people said version 2, so I'm going to do that here. And maybe on the next example, I'll do the other way. We'll kind of see where we're at. I am not going to try to shrink this down so that it fits on 2 lines. Okay, 2 over a minus 1 plus 4 over a minus 4, all over 6, which is over a squared minus 5a plus 4. Okay, if we're going to do it the second method, we're going to find the least common denominator of all the little fractions. How many little fractions do I have? I'm seeing 3, and I'm seeing 4, and I'm seeing 2. 3. Little fractions are just any fraction that isn't the giant one. Here's my giant one. I've got 3 smaller ones. 3 little fractions I need to find the least common denominator for. I notice my denominators include addition and subtraction, which means I need to do some factoring in order to make this happen. Can I factor a minus 1? No, but I remember it's in parentheses and I move on. Can I factor a minus 4? No, but I remember it's in parentheses and I move on. Can I factor a squared minus 5a plus 4? Yeah. But Lacey, your shortcut? Shortcut, 2 things multiply to 4 and add to negative 5. Negative 4, negative 1. So I'm going to be lazy and just say, hey, that's an a minus 1 and an a minus 4. Oh, that's nice of it being the same ones as what's on top. It's almost like I don't want to make it completely evil all the time. Emphasis on all the time. Okay. These 3 fractions, what's the least common denominator? A minus 1 and a minus 4. I don't know why I'm writing in green anymore. So I multiply that on both top and bottom of the big fraction. Remembering it's over 1, remembering to distribute. This is where this method can save you a heck of a ton of work. Because right now, when I go to multiply this, can you tell what's going to cancel out? The a minus 1. Can I cancel it out right away? Yeah. I'm left with a 2 being multiplied by an a minus 4. Don't forget the plus sign that's right here. Continue to distribute. When I multiply these, can you tell what's going to cancel out? A minus 4. I'm going to be left with a 4 and an a minus 1. And I multiply the bottom. Now technically I'm distributing, but there's only one term here. So it's not really distributing, it's just multiplying. Can you tell what's going to cancel out? Both the a minus 1 and the a minus 4, leaving you with 6. That complex fraction just became an ugly looking fraction. But it's a singular fraction. Now what? Distribute. Do the actual multiplication. Remember, if there's addition or subtraction not in parentheses, you cannot cross anything off from top and bottom. You have to simplify the top and then try to factor to simplify. So we distribute the 2, we distribute the 4. Keep in mind, if that was a minus, it'd be a negative 4. 2a minus 8 plus 4a minus 4 all over 6. And I combine like terms. 2a plus 4a is 6a. Negative 8 minus 4 is negative 12 over 6. Can I simplify? Yes, I can factor a 6 out. And the 6's will cancel. A minus 2 is our final answer. When you have to factor those denominators, the what cancels out becomes a lot easier to see, and that's where this method tends to shine a little bit more. The only problem, again, is that it's less intuitive. So if you're a person who, like, I can't remember typically steps on what to do, this is giving you more steps of things to remember versus the first method is just remembering the rules we've already talked about. Okay. Final example. Do you want me to continue to do the second version, or would you like to see one of me doing the first version? A couple people who said something said second. Okay. So, least common denominator of all my baby fractions. How many of them are there? 4 fractions to look at. I see a denominator of an x plus 5. Can I factor it? Parentheses. X minus 6. Parentheses. 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 None of those denominators factor. And in fact, a lot of the complex fractions you're going to see today, you're not going to see a whole lot of factoring. Or if you do, it's going to be like this one where one of them factors and the other one's match factors. Because I'm not trying to make it completely evil. Our least common denominator is going to be x plus 5, x minus 6. Always remember it's over 1. Always remember to distribute. Multiply the first one, what am I going to get? 4x minus 6. Good. Multiply the second one. What am I going to get? 9 times the quantity x plus 5. Don't forget what's between them. Plus, over. Denominator. Multiplying here, I'm left with 5 and x plus 5. Don't forget what's between them. Last multiplication. 8 and x minus 6. I noticed an x plus 5 on top and bottom and an x minus 6 on top and bottom. Can I cross them off? No. Why not? The only way you can cross them off is if everything is multiplication. Is that a multiply? Is that a multiply? Addition and subtraction have to be in parentheses, have to be in a factored form. I'm sorry, I asked a trick question. Some of you fell for it. Distribute, combine like terms, factor, simplify. 4x minus 24 plus 9x plus 45 over 5x plus 25 minus 8x plus 48. Distribute that negative with and combine. 13x plus 21 over negative 3x plus 73. Distribute, combine like terms, factor was next. Can I factor 13x plus 21? Can I factor negative 3x plus 73? Technically, they don't want the negative there. They'd factor out the negative. They'd put it in front. I'm not too worried about that on these ones. Get that negative out of the denominator if other things simplify. Otherwise, this is fine. Sometimes the answer's not pretty. And that's the reality of it. That's all I got for you today. Today's our second book assignment. Remember, on your book assignments, on the top of the assignment, I want to see not only the page number, but if it says day 1 or day 2, make sure you're writing that as well. That way, when I'm going through and grading assignments, I don't have to question which assignment it is. Especially, some of y'all don't do the problems in order, and then I'm really trying to figure it out. Okay, questions 5 through 8, 14 through 17, 36 through 37, and 50 through 52. Not all of these are complex fraction problems. Some of them are just straight adding and subtracting problems.